Next property is chain rule property. Property 2. Property 2 is if u is function of x and y, v is function of x and y, and x is function of r and s, and y is again function of r and s. So you can view it as u and v are finally function of r and s. So because in the first pair u and v are functions, x and y are proper variables. In second pair x and y are functions and r and s are variables. So as I told you the thumb rule, so according to thumb rule here you can find Jacobian of uv with respect to xy, and here you can find Jacobian of xy with respect to r and s. So the property is that Jacobian of uv with respect to xy into Jacobian of xy with respect to r and s is finally the Jacobian of uv with respect to r and s. So this is the next property, and this is also called chain rule property. Chain rule property. You know that dy by dx you already or you are already using dy by dx is equal to dy by dt and dt by dx. This is called chain rule. The same thing apply here, duv by del xy by del r. So this is called the chain rule. Now we will take some question to demonstrate the chain rule. So initially take a small question, a simple question. Example, let u is equal to x square minus y square and v is equal to 2xy. Again, x is equal to r cos theta, y is equal to r sin theta. So the requirement is that find Jacobian of u and v with respect to r and theta. So you can see that you cannot directly find Jacobian of u and v with respect to r theta y, because you cannot differentiate u directly with respect to r and directly with respect to theta, and same for v. So we will apply the chain rule. So how will we applying chain rule? As a thumb rule, u and v are functions, xy are variables. So we will find Jacobian of uv with respect to x and y. So we know this is del u by del x means 2x, del u by del y means minus 2y, del v by del x means 2y, and del v by del y means 2x. So you can take 2 common from each row, so it is 4, and x square plus y square, so x square plus y square. So this is our Jacobian of uv with respect to xy. And now again apply the thumb rule to the second pair, this x is equal to r cos theta, y is equal to r sin theta. So Jacobian of xy with respect to r theta. So I have already evaluated this Jacobian during the introduction to Jacobians. So again I am performing the short calculation. Del x by del r is equal to cos theta, and del x by del theta is minus r sin theta. Then del y by del r is equal to sin theta, and del y by del theta is equal to r cos theta. So once you open the determinant, you will get r. So now how to find this Jacobian? Jacobian of uv with respect to r theta. So using this chain rule, chain rule is still with you. So Jacobian of uv with respect to r theta is equal to Jacobian of uv with respect to xy into Jacobian of xy with respect to r theta. So put these values. So this is equal to Jacobian of uv with respect to xy. This is equal to 4 times x square plus y square into Jacobian of xy with respect to r theta is r. So this is equal to 4x square plus y square plus r, but again x square plus y square is equal to r square. So this is equal to 4r square r, and finally this is 4r cube. So this is how we use the chain rule property to find a Jacobian. So we take one more example to show the chain rule. So this example is u is equal to x plus y plus z, and uv is equal to the problem u square v is equal to y plus z, and u cube w is equal to z. Then find what should we find? Find Jacobian of u, v, and w with respect to x, y, and z. So here you should observe that we don't have explicit function u/w as a function of xyz, or explicit function xyz as a function of u/w. So what we do is that we assign let we assign new names. A is equal to u is equal to x plus y plus z. Then b is equal to u square v is equal to y plus z, and c is equal to u cube w is equal to z. So we can treat abc as a function of u/w separately, and abc is a function of xyz separately. So we can find Jacobian of abc with respect to u, v, and w. So what is this? Del a by del u is equal to 1, del a by del v is 0, del a by del w is 0. Then del v by del u is equal to 2u v. Del a by del v is equal to u square, and del a by del w is 0. Del v by del w is 0. Then del c by del u, this is 3u square w, and del c by del v, so c don't have v, so this is 0, and del c by del w is u cube. So this determinant comes out to be u to the power 5. And now we can find Jacobian of a, b, and c with respect to x, y, and z. So what is this? Jacobian of abc with respect to x, y, and z. So this is del a by del x is equal to 1, del a by del y is equal to 1, del a by del z is equal to 1, del b by del x, b does not have x, so 0, del b by del y 1, del b by del z 1. Then del c by del x, c is equal to z, so c is function of z purely. So this is 0, this is 0, and this is 1. So finally this is 1. So now how can we find Jacobian of uv with respect to x, y, and z? So here is what we will do. By chain rule, Jacobian of u, v, w with respect to x, y, and z. So this can be written as a chain rule Jacobian of u, v, w with respect to a, b, c into Jacobian of a, b, c with respect to x, y, and z. So we directly have this second Jacobian, but we don't have the first one. But we know from the property 1 that first can be calculated at its inverse. So this is equal to Jacobian of ABC with respect to U, V and W. Inverse of this into Jacobian of ABC with respect to Jacobian of ABC with respect to X, Y and Z. So this is 1, and what is this? This is u to the power 5. So this is equal to finally u to the power 5 and this minus 1 into the value of second one is 1. So finally we have u to the power minus 5. This is the Jacobian that we calculated with the help of chain rule. Our next example is, if u cube plus v cube is given by x plus y and u square plus v square is given by x cube plus y cube, then find what we will find Jacobian of uv with respect to x and y. So let us try to find it. So first we assign some names as we done in previous questions. Let a is equal to u cube plus v cube is equal to x plus y, and b is equal to u square plus v square is equal to x cube plus y cube. So we can find Jacobian of AB with respect to uv and with respect to xy separately. So first, Jacobian of AB with respect to uv. What is this? Del a by del u is equal to 3u square. Del a by del v is equal to 3v square. Del b by del u is equal to 2u, and del b by del v is equal to 2v. So you open the determinant to find 6 u square v minus 6 uv square, that is 6 uv u minus v. And as a second part we will find Jacobian of AB with respect to x and y. So this will come out to be del a by del x is 1, del a by del y is 1, del b by del x is 3x square, and this is 3y square. So we get 3 times y square minus x square. Now we apply the chain rule to find the required Jacobian. So Jacobian of uv with respect to x and y can be written by the chain rule as Jacobian of uv with respect to ab and Jacobian of ab with respect to x and y. So with the first property we will find this first Jacobian of uv with respect to ab as inverse of the first we found. So this will become Jacobian of uv with respect to ab inverse, and Jacobian of ab with respect to x and y. So what is our answer? We will get Jacobian of ab with respect to xy is 3 times y square minus x square, and that Jacobian of AB Jacobian of AB with respect to x and u and v, Jacobian of AB with respect to u and v, this is our 6uv 6u minus v. So this is 6uv u minus v. So 3 cancels 6 two times, and finally we get the answer. Our Jacobian of uv with respect to x and y, this is equal to y square minus x square divided by 2 times uv u minus v. Now next example, if u, v and w be the roots of lambda minus x whole cube plus lambda minus y whole cube plus lambda minus z whole cube is equal to 0, find the Jacobian of u, v, w with respect to x, y and z. So before applying the formula for Jacobian, we have to work out to find a relationship between u, v, w and x, y, z. So to do so, open the given equation, simplify it. So you will get lambda cube minus 3 lambda square x plus 3 lambda x square minus x cube plus lambda cube minus 3 lambda square y plus 3 lambda y square minus y cube plus lambda cube minus 3 lambda square z plus 3 lambda z square minus z cube. This is equal to 0. So this is a polynomial in terms of lambda. So collect the equal powers of lambda, means organize this in powers of lambda. So we will get 3 lambda cube minus 3 lambda square x plus y plus z plus 3 lambda x square plus y square plus z square minus x cube plus y cube plus z cube is equal to 0. So if u, v, w are the roots of this equation, if u, v, w be the roots of this equation, then you know formula. If u, v, w be the roots of this equation, then you know the sum of roots u plus v plus w will become. So before writing this, let me revise you. Remember that if ax cube plus bx square plus cx plus d is equal to 0, then sum of roots is minus b by a. Pairwise sum of pairwise product of roots is c by a, and product of all roots is minus d by a. So using this rule, we will get u plus v plus w. This is equal to x plus y plus z, and pairwise product sum uv plus vw plus wu. This is equal to x square plus y square plus z square, and product of all the roots uvw. This is equal to 1 by 3 x cube plus y cube plus z cube. So now we have established the relationship between u, v, w and x, y, z. So we can now proceed to find our Jacobians. So at the same point, let us name our relations as a is equal to this, b is equal to this, and c is equal to this, so that we can find the Jacobian of ABC with respect to x, y, and z. So what will be Jacobian of ABC with respect to x, y, z? So let us write here. Jacobian of ABC with respect to x, y, and z. So this will become del a by del x is 1, del a by del y is 1, del a by del z is 1. Then del b by del x is 2x, del b by del y is 2y, and this is 2z. Then del c by del x is x square, then y square, then z square. As a thumb rule, you already know how to solve the determinants. Take column operations. So C2 minus C1 and C3 minus C1. So transform into this will transform into 1 0 0, and you can take 2 common from the second row. So 2 is here, and x y minus x z minus x. Then this is x square, this is y square minus x square, this is z square minus x square. So again you can take y minus x common from the second row, and second column, and z minus x common from the third column. So now thus we get Jacobians of ABC with respect to x, y and z is equal to y minus x, z minus x, 1 0 0, then x1 1, and then x square y plus x z plus x. This is very easy to open. So finally you will get x minus y, y minus z, and z minus x, and here is a 2. So this will become 2 times x minus y, y minus z, and z minus x. Now we will find the Jacobian of ABC with respect to UVW. So Jacobian of ABC with respect to U, V and W. So let me write again what ABC was. So A was U plus V plus W. B was UV plus VW plus WU, and C was UVW. So we will find this del A by del U is 1, and again 1 and again 1. Then del V by del U is V plus W, then U plus W, then U plus V, and V del C by del U, VW, then similarly UW and UV. Again perform the column operation. Column operation C2 minus C1. So this will lead to 1 0 0. V plus W, U minus V, and U minus W. Then VW and WU minus V, and VU minus W. So you can take U minus V common from second column, and U minus W common from third column. So U minus V and U minus W, the rest determinant is 1 0 0, V plus W 1 1, and VW WV. So this is now very easy to open, and finally you will get minus U minus V, V minus W, W minus U. So we have obtained two Jacobians, ABC with respect to XYZ and ABC with respect to UVW. So finally we will find our required Jacobian. Jacobian of UVW with respect to x, y and z. So as a chain rule, we will write this as Jacobian of u, v, w with respect to a, b and c. And remember, this is just the inverse of this one. So into Jacobian of ABC with respect to x, y and z, and this is directly what we have obtained. So we will write this as 2 times x minus y, y minus z, z minus x, and that divided by inverse of ABC with respect to UVW. So this will become minus U minus V, V minus W, and W minus U. So this is the Jacobian of UVW with respect to XYZ, and we obtain with the help of chain rule. So we have solved multiple questions of Jacobians with the help of chain rule, and in next part 4, we will discuss the property 3 of Jacobians. So keep in contact and see the next video.